Alright guys, welcome back to Algos Made Simple. Got a medium Leetcode problem here today, but I think once you see the solution and realize how simple it is and how simple we can think about this problem, you'll really feel comfortable with it and feel like you can knock it out whenever you see it. So with that being said, let's jump into it. Leetcode 153, find minimum in rotated sorted array. It states, suppose an array of length n sorted in ascending order is rotated between 1 and n times. For example, the array nums equals 0, 1, 2, 4, 5, 6, 7 might become 4, 5, 6, 7, 0, 1, 2 if it was rotated 4 times, 0, 1, 2, 4, 5, 6, 7 if it was rotated 7 times. Notice that rotating an array a at index 0, a index 1, a index 2, a index n minus 1 one time results in the array a index n minus 1, a index 0, a index 1, a index 2, a index n minus 2. And all they're showing us there is that, hey, if this is rotated one time, this moves to the leftmost and everything just moves to the right over 1. So that's all it's showing us. Given the sorted rotated array nums of unique elements, return the minimum element of this array. You must write an algorithm that runs in O log n time. So I'd let the interviewer know, I understand I'm getting an array that at one point was completely sorted from least to greatest, left to right. And at some point it was rotated. It may be rotated enough times that it's still sorted completely from left to right, or I could be dealing with two rotated sections where I'm rotated from the left to a point, and at that point it starts a new rotated or a new sorted array or a new portion of the array that's sorted as well. And I know that I'm trying to find the minimum element, and I have to do an O log of n, so I can't just iterate through it and try to find the smallest number, and I can't just run the min function or anything like that. So I understand conceptually what I'm trying to do here and what the task that's been given to me. So that's confirmed. Going to the example here, we've got input nums equals 3, 4, 5, 1, 2. Again, if you can look at every number, you would know 1, that's the output. But we don't want to have to look at every single number here. So how would we do something like this? Well, it's O log n. So you should think immediately, we're not going to be looking through this whole thing, we'll probably just be looking through half of it. That sounds like a binary search to me, and it should sound like a binary search to you as well. One of the easier algorithms to kind of wrap your head around here. But very, very useful. So with that being said, a binary search, we're going to have a left pointer, a right pointer, and a middle pointer. That's kind of the core components of that algorithm. And then we know, okay, we got a left and right and middle. What do we know about this thing if it's rotated? Well, if it's rotated all the way back to the way it was, then our minimum number will be on the left. The only time that the left is going to be less than the right is in that case. Because if you look here, on this rotated 4 times, we have the 4 and the 2. Okay, our left is greater than the right. If we bump this 1 over here and move this 2 over here, our 2 is still going to be greater than that 1, and so on and so forth until we get back to where this 0 is over here. So if the first thing we can check out here is if the left is less than the right, then we have our normal sorted array back. We're back to where we started. We're back to the original. Let's just return the left as the minimum. That's fantastic. That's your easiest base case here, is that you've just got a sorted array. That would be fantastic. If that's not the case, what can we do? We know if that's not the case that this left is greater than the right. Well, we're getting our middle too, so what we would do then, if this middle is greater than the number on the left, then we know we have not came down. We've just continued to ascend from the left that we know is greater than the right. We've just continued to ascend up to this middle. So if we know that, then we know we want to search the right. So if middle greater than the left, search the right, search from the middle to the right. If the opposite's true, if that middle is less than the left, so say you had 3, 0, 1, then we know at some point this 3 came down, or whatever, this section has come down. Even if it's right at the middle, it could have came down there, but we've stopped ascending. We've descended at some point, and it could be in the middle between left and middle, or it could just be the middle. So at that point, we want to search in the left. So we want to search the left side of the array from that left index plus 1 over to the middle. And that's all there is to this problem, guys. That's how you'll find the minimum. That's how you'll cut it down to O log of n. Again, if the first thing's correct, you would just be returning the left just right off the bat. Just one little look. That would be an that'd be constant time, O of 1. If we don't get that lucky, then we're over here. If middle greater than left, search right. We're just going to search the right. We're just going to run a for loop on the right. That's going to get us that O log of n. Again, the opposite, if the middle's less than the left, we're going to search this left, and again, that's just going to be looking through those. It's going to be log of n because we don't have to even deal with this part if that's true. So what does that look like coded up? Because it should be pretty simplistic to understand. Like, you should be able to wrap your head around, okay, I'm looking for where this number is going to be. Again, just going through it one more time. If it's back to where it started, if this was 1, 2, 3, 4, 5, then this 1 is going to be the smallest element. And that's the only time the left is going to be the smallest. Now, if my middle number is bigger than my left, that means I've continued to ascend. So why would I check the left? I know I'm not descending much there. I've continued to ascend. My descent is going to be somewhere on the right. Now, if the middle is less than the left, then I know I've descended at some point, and my minimum's over here on this side. So diving into coding it, which will hopefully even clear it up even further, we've got min rotated sorted is what we'll call it, and nums passing through. And again, going with our game plan, we know we need a left. The left's going to be nums at index 0. We know we need a right. That's going to be nums at length of nums minus 1. That's going to get us the rightmost index of the array. Then we know we need a middle to check that as well, and that middle is going to be nums length of nums for your index minus 1, and that's going to be divided by 2. But we're going to do the double division operator so that way it gets a rounded number no matter what. We have something to work with. We don't have a float point number there. So going from that, all right, we've got our indexes. What's the very first thing we said we'd search for? Now we have our indexes. If the nums at left is less than the nums at the right, then hey, party on. We're just returning that num on the left because that means we have our original array back. This is just a sorted array. It's somebody asking you, hey, I've got an array 1, 2, 3, 4, 5. What's the lowest? Okay, it's the number on the left. Now, if that's not the case, which in most of these examples probably it will not be the case, and you got to prepare for that, then we just need to check and see if this number in the middle is greater than the number on the left. And we know they're all going to be unique elements you don't have to worry about or equal to or anything like that. And what we'll do here, if that's the case, if this middle number is greater than the number on the left, after we've already established that the number on the left is greater than the number on the right, then we know, hey, let's search the right. So we'll say for num in num's middle to the end of the array, or what end of this sectioned off array, and we'll just simply say, okay, if this number is less than, and we need to set our resolution up here. I skipped that part. If you need to have something to base it off, so we'll set our resolution to nums. You can set it at the index 0. We'll just say nums at middle. So if num is less than our resolution, then we want to go ahead and set resolution to equal to num. That's our new min. Alright, if this is not the case, now I'm not going to do an else, I'm going to do another else if, just to spell it out even clearer. If this num's a middle is less than the number on the left, that means at some point either at the middle or some point and get in the middle, we've descended. This number is less than what the left one is, so we've descended at some point. So again, coming up here, so that'd be having 3, 0, 1. That means at some point, if this 1 is less than this 3, we've descended. It could be right here at the 1, it could be at the 0, etc., etc. We've descended. You could have 3, 4, 1, whatever. So putting that back to what it was. Let's go here, and this will be the exact same thing here. But what we're going to do is, I'm going to still type it out here. For num in nums, from index 0, and you could just do 0 to 1, but let's just make it as simple as possible. You can go 0 up to the middle, and you're going to say, and remember we already have that middle because we set the middle equal to our resolution. So we already have that middle there, so that's why we're going up to the middle. If you didn't have that as your resolution, you'd do middle plus 1, so you make sure you get that in there. And we'll just say if num is less than resolution, then resolution equals the num. After we get through all these conditionals, we're just going to simply return the resolution. So let me get this all on one page for you so it looks a little bit nicer. You can kind of really see what's going on. All right, again, what we're doing here, and this happens O of log n, we're setting our left, we're setting our right, we're setting our middle, that's binary search. We're setting our resolution to be nums at middle. You could do it 0 or wherever, but you'd have to change the problem up a little bit. And all we're checking is, okay, is this the original array? Is this just, 1, 2, 3, 4, 5, just in ascending order, left to right? Because if it is, then nums left is less than the number on the right. We can just return nums left, done. If it's not, if that number on the left is greater than the number on the right, is this number at the middle greater than the number on the left? Like, are we just ascending, ascending, ascending? If that's the case, then I want to check the right because the minimum is going to be over here on the right. Okay, if that's not the case, if this number at the middle is less than the number at the left, I know I've come down from that number at the left at some point, whether it's right at the middle or whether it's before the middle, I've come down from that number at the left. I need to check the left side. And you just simply iterate through that cutoff portion of the array, boom, return resolution. So simple as that for this one, guys. I appreciate you watching. If you've got a simpler way to do this one, please let me know, but I think this is very simplistic if you just wrap your head around, hey, it's a binary search, and I just have to figure out which side of this array I'm searching on. That's all there is to it. Again, your game plan here spells out the entire problem for you. So thanks, guys. If you found this useful, like and subscribe, and I'll catch you in the next one.